So, for the first question, the normal force is the force exerted by a surface perpendicular to the contact point. In the case of a rider at the top of a loop, the normal force is directed towards the center of the loop and it acts as a centripetal force required to keep the rider moving in a circular path. To determine the minimum possible speed a rider can have at the top of the loop, we need to consider the forces acting on the rider. At the top of the loop, the net force on the rider consists of two components, gravitational force and normal force. So gravitational force, the force of gravity, acts vertically downward on the rider. This force provides a downward acceleration and contributes to the net force. Normal force, the normal force acts as a perpendicular to the surface of the loop, directed towards the center of the loop. This force counteracts the gravitational force and provides the necessary centripetal force for the circular motion. For the rider to remain at the top of the loop without falling, the net force must be equal to greater than zero. This means that the normal force must be sufficient to balance the gravitational zone. Setting the net force equal to zero, so let's say net force equals mg minus n equals zero, solving for the normal force would be n equals mg. In this case, the normal force is equal to the gravitational force. This ensures that the rider experiences an upward force equal to their weight, which allows for a balanced net force and maintains their contact with the loop. To calculate the minimum possible speed a rider can have at the top of the loop, we will need to consider the forces as described above and apply principles of circular motion, equating the gravitational force for the necessary centripetal force. The minimum speed required will depend on the radius of the loop and the acceleration due to gravity.